Okay, let's talk about the first law of exponents, right? And that law is called the product law, right? Look at this word, product. In maths, when things are adding each other, let's say, for example, we have 2 plus 2. We call this a sum, right? But when things are multiplying each other, we call this a product. This means that this law, this first law, involves things multiplying each other, right? Now, let's do an example, especially with the 2 we're looking at. So if, for example, we have 2 times 2, usually, yes, you can just write 4, right? But according to this law, we can even write this product in a different way. We can, according to this law, we can say it is 2, it is multiplying itself how many times? 2 times, right? Where did we get the 2? Usually, when you see a number or a variable, right, and it doesn't have an exponent, just know that its exponent is 1. Therefore, that 1 plus 1 there gives us the 2 there, right? So, in other words, the law is saying when the bases are the same, in this case being 2, right? You simply just do what? Write that base and then you add their exponents. Let me give another example. Let's say you have 2 times 2 to the exponent 2, for example, right? I said that when you see a number or a variable and it doesn't have an exponent, just know its exponent is what? Is 1, right? So in this case, it means 2 to the exponent 1 times 2 to the exponent 2 will give us 2. And then we add those exponents. It's going to be 1 plus 2. In this case, being what? 2 to the exponent 3. Are we together? Now, that's what the law is saying, right? When the bases are the same, in this case 2 and 2, you simply just do what? You keep the base and then you do what? You add the exponents. That is the product law, right? Now, here we are just using numbers, right? Let's look at it as when we are using variables. A variable is what? An unknown number, a number we don't know yet, right? Let's say, for example, you have the favorite letter, which is x. X times x. Usually multiplication in maths can be written as a dot, can be written as the multiplication we know, or sometimes we can even use brackets, right? So this is another way of writing multiplication. So x times x will give us what? Remember I said, when you see a number or a variable and then it doesn't have an exponent, know that its exponent is what? It's 1, right? Therefore, in this case, using the product law, we are going to say x to the exponent 1 times x to the exponent 1 equals to, remember we said we do what? We keep the base, which in this case, it is x, right? And then you do what? You add the exponents. So it's going to be 1 plus 1, which is going to be x to the exponent 2. Are we following? Yes. So that is an example of how you can use the product law, right? Now, sometimes you can have something like this. Remember, with a variable has an exponent and can also have a coefficient, right? For example, a variable, if a variable is like this, x, I said if it's a variable but it doesn't have an exponent, you must know that the exponent is what? It's 1, right? Now, a coefficient is the number, you'd usually see it here. It would be written with the x, right? Now, if a variable like x doesn't have a coefficient, it means its coefficient is what? It's 1, right? Now, if I can say x times, for example, 2x, right? How would you do this? It's still the product law, right? Somehow they're still multiplying each other, right? Your product law, you get it from here because the bases are the same, right? But then they are being accompanied by what? By the 2 there, right? And then we said since a variable doesn't have a coefficient, its coefficient is what? It's 1, right? And then the exponents would be 1 and also 1 here, right? What do you do in this case? You multiply a coefficient with a coefficient, a variable with a variable. Are we together? In this case, let's start with variables first. We know that using the product law, we are going to keep the exponent and then add those. We keep the base and add those exponents, right? In this case, we're going to have to the exponent 2. Now, as for this coefficients, since they are not the same, right? We multiply them the way we usually multiply them, right? Which is going to be 1 times 2. And in this case, it's going to give you what? 2. Then this is your answer, right? Now, let's look at it, for example, if maybe the coefficients are the same. Let's say, for example, you have 2x times 2x equals to, what do? Exponent is what? It's 1. Exponent is 1. And then look at the coefficients or these numbers here. The bases are the same, right? Or they are the same. What is the exponent? Exponent is also 1 and 1, right? What do? With the variables first, we say x to the exponent what? To the exponent 2, according to the product law. And then for this one, you also say 2, and then you add the exponents, which is going to be 2. And then this can be simplified to 4x to the exponent 2. Are we together? Now, remember I also said that multiplication can also be written as a bracket with brackets, right? So imagine we have something like into 2x to the exponent 3, close bracket, and then open bracket, 4x to the exponent, for example, 5, right? You still do the same thing. If you can look at this, you have the same basis, right? That means you're simply just going to do what? To add the exponents. Equals to, we're going to say x and then 3 plus 5, which is going to give us what? 8. And then I said, since these coefficients are not the same, right? You can simply just do what? Multiply them. It's going to be 2 times 4, which is going to give you what? 8. Are we together? Or someone might see that actually this 4 here, right, can be written as 2 to the exponent 2, whereby now the basis will be the same. In other words, I'm saying that 4 there can be written also as 2 to the exponent 2, right? And then in this case, you can simply just say, since the basis are this, the basis of this are the same of the coefficients, you can simply just do what? You say 2 and then you add the exponents. Remember the exponent here is what? Is 1, right? 2, so 1 plus 2, it gives you 3. And if you can check, 2 to the exponent 3 is actually 8. Are we together? So there are many ways of doing these things in maths. That is what I'm saying. Maths is very easy. You just have to find your way of doing things, right? Now, let's take it a little bit further, right? To still demonstrate the product law in many ways. Now, sometimes you might have something like x to the exponent negative 2 times x to the exponent, let's say for example 3, right? The law is still the same. When the bases are the same, you add the exponents. Let's try to add the exponents, right? We say since the bases are the same, we're going to keep the exponent, the base, and then we add the exponents. How do we add them? We're going to say negative 2 and then plus 3, which will give us x to the exponent 1. Are we together? Just because you're seeing the negative here doesn't mean you have to panic. It's still the same thing, right? Let me give you another example. Let's say, for example, you have, let's say you have x to the exponent 4, right? And then multiply by x to the exponent negative 3, right? You still do the same thing. The bases are the same and you're multiplying, which is your product. You still keep the base and then you add the exponents. You're going to say 4 plus the other one, right? To add this one, I prefer that you put it into brackets. Negative 3. Negative 3, right? In this one, you have to know that when you addition multiply by subtraction will give you what? Negative. In other words, positive multiply by negative will give you what? Negative, right? So this is the same as saying x to the exponent 4 minus 3, which is going to be x to the exponent 1. Are we together? Now, also, the question could also come in this form, right? You can have x, right, to the exponent 4 times 1 over x to the exponent 5, right? This is another law we are still going to look at. Some of you call this a law, but this is actually an identity of which this question we're going to look at. Right now I can solve it, but then I'm going to explain it as we are progressing, right? Something like this, you can say equals to, and then x to the exponent 4, and then multiply by x to the exponent negative 5. Keep this in mind, keep this in mind. How did I change this to this? I'm going to explain it when I'm talking about the identities of exponents. There's a difference between the laws of exponents and also the identities of exponents. We have 5 laws of exponents, right? And then we have 4 identities of exponents. The two are not the same thing. I'm still going to explain. Watch out for the series where I'll be making the identities after I'm done with the laws of exponents, right? So in this case, you still have the same basis and then you just add the exponents, right? If we were to do this, we are going to say equals to x to the exponent 4, sorry, x to the exponent 4, yes, and then plus into -5, right? -5, right? And then we can say equals to x, and then positive times negative is going to give us negative, right? So we have 4 minus 5, which is equals to, we are going to have x to the exponent -1, of which you can write it like this, or you can write this as 1 over x. I am still going to explain how we got from here to here. Are we together? Now, let's look at something else also. Remember, here we are talking about x, whereby our one of our exponents is negative. It's also possible, right? Now, sometimes you can also have this in such a way that uh, your exponent is actually a fraction, right? Let's say, for example, you have x to the exponent 1 over 2 times x to the exponent, let's just say again 1 over 2, right? But the laws still apply. Remember, when the bases are the same, you simply do what? You add the exponents, right? So in this case, it's going to be equals to x, and then let's add the exponents. It's 1 over 2 plus 1 over 2. 1 over 2, it is 0, 0.5. And 0, 0.5 in English, we call it half. Are we together? So what is half plus half? Half and half. Half and half gives you what? 1, right? So in other words, this is just going to be x to the exponent 1, and then which is the same as just x. Are we together? So in other words, you also need to learn how to add your fractions, how to subtract your fractions, how to multiply your fractions, how to divide your fractions, of which this also, watch out for my other videos where I'll be talking about fractions, right? So pretty much I'm trying to show you that maths is actually easy by teaching you all these things, right? Just watch out for my series on fractions. I'm going to teach you all this. Maths is easy. Maths is easy. Don't worry. Uh, Now, let's erase this one, right? And now, let's talk about, or let me give you another question regarding these fractions. Maybe you can do this one. Let's say you have x to the exponent 1 over 2 multiplied by x to the exponent 1 over 4. Remember I said you simply just do what? Add your exponent, and then you you keep one base and then add your exponents. Do this one and give me the answer in the comments. I just want to see what you got for this one, right? Now, let me give you a question, and I want you to see something, right? I want you to see something regarding this. Let me look for a question. Like, I saw this interesting question. Uh, it looks like some questions look hard when you look at them, right? But the minute you start to break it down, you just see like, ah, this is nothing, right? I saw this question. It says into 2 2x squared and then y to the exponent 3 close bracket and then open bracket 3x to the exponent -1 and then y to the exponent 4 close bracket all over 6x to the exponent 5 and then y to the exponent -2. it's a question like this, right? When you look at it, I think the reason why sometimes we think maths is hard is because we see a question like this and we start to be scared. We think maybe it's something we've never seen. But if you can look at this question, it is simply just the product law. It's pretty much what I've been teaching you. You just have to look at this carefully. Remember, I once said that multiplication can also be written as brackets, right? In other words, I'm saying if something is written like this, you can even just remove these brackets as long as there's no addition and subtraction in between, right? You can just replace this with multiplication. Are we together? And then the other thing that maybe you might be scared of is because you are seeing a fraction, right? Because you're seeing a fraction here, it means we need to tap into the other law. But let me first show you if maybe we're looking at the numerator only, right? On the numerator, learn to break this into different sections, right? For example, you can see you have a coefficient here and also a coefficient here, right? The coefficient of this one is 1. The coefficient of this y is also 1 because there's not, if there's no, like I said, when there's no coefficient, it means the coefficient is 1, right? Now, with the numerator only, looking at only the numerator, if we were to do this one, we can simply just multiply the coefficients, and then for the variables here, since the variables are the same, for example, we have the variable of x and also the variable x, we just keep the variable and then add the exponents. The same thing we're going to do also for y, right? We can just simply do this, right? Let's look, for example, let's start with, for example, y, right? We are going to have y, and then it is 3 plus 4, which is going to be 7. Because we just kept the base and then added the exponents. 3 plus 4 gave us 7, right? And then let's look at for x, right? For x, it is 2 plus minus 1. 2 plus into minus 1, right? It's going to give us positive times negative is going to give us negative. So it's going to be 2 minus 1, right? Equals to 1. In other words, the exponent of x is going to be 1. Can you see it? Now, let's multiply all the coefficients. 2 times 1 still gives us 2. 2 times 3 gives us 6. And then that 6 times 1 still gives us what? Just 6. So we are still at 6, right? Over. On this one, let's write the denominator then. We are going to have 6 x 5 and then y to the exponent negative 2. Now, I'm going to stop it here, right? Reason being, this now requires the second law, of which we are going to watch in the next video. This was called the product law. It has helped us to solve this until here. Now, let's look at the next video to be able to check what we call, instead of the product law, it is called the quotient law. So, for now, let's move to the next video to learn about the quotient law. So now, let me erase until this point. Remember, we're going to continue with this one to be able to solve it using law number 2, which is called the quotient law. So see you in the next video.